Now it is time to learn what EntityManager is and how we can actually persist our entity. A connection to a database is represented by an EntityManager instance, which also provides functionality for performing operations on a database. Many applications require multiple database connections during their lifetime. For instance, in a web application, it is common to establish a separate database connection using a separate EntityManager instance for every HTTP request. There is a special object of type EntityManager Factory that is used to manage instantiation of EntityManager instances. An EntityManager Factory is constructed for a specific database, and by managing resources efficiently, provides an efficient way to construct multiple EntityManager instances for that database. Operations that modify the content of a database require active transactions. Transactions are managed by an entity transaction instance obtained from the EntityManager. An EntityManager instance also functions as a factory for query instances, which are needed for executing queries on the database. So the first step is to obtain EntityManager. To do this, we need to obtain an EntityManager factory that represents the relevant database, and then we can use that factory instance to get an EntityManager instance. JPA requires the definition of the persistence unit in an XML file in order to be able to generate an EntityManager factory. To configure EntityManager factory, we need to create persistence.xml file. There is also a conventional place where we need to put this file in Maven project. JPA implementation would look for this file in the src main resources meta-inf folder. And here you can see where we put this file. But before we add configurations to this file, let's make sure that we added all required dependencies into the class path. I open pom.xml. So we have here added our Jakarta persistence and Hibernate core dependency. Because, as we learned already, JPA is just a set of interfaces, contracts, but to make things actually work, we need to add some JPA implementation. And in this course, we are going to use Hibernate as JPA implementation. Also, let's add MySQL connector to the class path. It is also required because we are going to use MySQL Server during the course as our persistence storage. Let's now open persistence.xml file. I am going to give you a basic overview of key elements of the persistence.xml file. The persistence.xml configuration file is used to configure a given JPA persistence unit. The persistence unit defines all the metadata required to bootstrap an EntityManager factory, like entity mappings, data source, and transaction settings, as well as JPA provider configuration properties. The root tag is a persistence, and it defines the JPA version. You can use JPA with a very short, basic configuration. You only need a persistence element as the root element and a persistence unit element with a name attribute. The attribute is used to identify the persistence unit, and you can use it during the bootstrapping process to instantiate a specific EntityManager factory. Having the basic default configuration, we also have to accept some default configurations. Let me cover some details of basic configuration. Your persistence provider scans the root of your persistence unit and adds all annotated managed persistence classes to the persistence unit. If your meta-inf directory contains a file called ORM.xml, it gets treated as a mapping file and included mapping information get used. I didn't show you example of ORM.xml file yet, but in short, you can use XML configuration to configure entities instead of annotations. Today, in this lesson, we used JPA annotations to configure our JPA entities, but theoretically, You can use XML configuration to not mix up Java source code and JPA configuration in one class. But this is matter of the coding style. Both ways of configuration are fine. In case you don't configure any database connection, JPA therefore expects that you provide a data source at a runtime. Or you can specify database properties to establish database connection. I'm going to show you how to do this in a few minutes. All JPA implementations support a set of proprietary configuration parameters. Examples for that are the login configuration in EclipseLink JPA or Hibernate's database dialect. As you don't define any of them in the specific basic configuration, you also rely on all provider-specific defaults. But during the course, we are going to learn key and the most popular configuration parameters. Let me also explain one more important concept before you see how to configure transactions type in the persistence.xml. Usually, in persistence.xml file, we have opportunity to configure transaction type. What is it? And what transaction types can be used? The transaction management is one of the most important Java persistence API aspects. If you are using Hibernate or any other JPA provider, you should know how valuable transaction management is. The JPA transaction determines when the new, modified, or deleted entity is synchronized with the database. There is no way to talk about JPA transaction management without mention persistence context. What is the persistence context? In short, the persistence context is a named session of entities. There are two main types of transactions: JTA transactions and resource local transactions. Let's learn what is the difference between these types of transactions. JTA, Java Transaction API, is an API for managing transactions in Java. It has a few crucial steps according to the transaction lifecycle. Transaction synchronization, the process in which transactions becomes registered in a persistence context. Transaction association, the moment of persistence context connecting with transaction. Transaction propagation, the moment of persistence context sharing. An application ecosystem may be the only one persistence context connected to the JTA, and all entity managers within a transaction must have the same persistence context. One more type of transaction management exists in JPA ecosystem: resource local transaction. What does it mean? It means that transaction management is 100% by your control. Implementation of it happens with the implementation of entity transaction. There are some disadvantages of that. For example, you may get a legal state exception when some transaction is already started and you try to start the new one. The same exception is caused in the case of commit or rollback without an active transaction. But during the course, I'm going to teach you how to use transactions like a pro. In the following lessons, we are going to review different propagation levels. What is it? In short, it is a flow of creating, avoiding, and passing transaction from method to method. So, what would be the conclusion? In most cases, resource local is fine. This would use basic JDBC level transactions. The downside is that the transaction is local to the JPA persistence unit. So, if you want a transaction that spawns multiple persistence units or other databases, then resource local may not be good enough. JTA is also used for managing transactions across systems like GMS and GCA, but that's fairly exotic usage for most of us. To use JTA, you need support for it in your application server, and also support from the JDBC driver. So, let's get back to our persistence XML configuration. Now you know two main transaction types. The used transaction type depends on the environment in which you deploy your application. In a Jakarta EE environment, JPA expects that the container provides a GTA-compliant connection provider. In a Java SE environment, it uses a resource local transaction instead. Here in the file I left commented lines, please explore them. You can see how I use transaction type property of persistence unit element. It can be resource local or GTA. The GTA data source and non-GTA data source elements are mostly used in Jakarta EE environments. They enable you to reference the GNDI name of a data source that is or is not compliant with the Java Transaction API. If you don't use any of these two elements, you need to either configure a default GTA data source for your container or provide the GNDI name of a data source at deploy time. And if you are using JPA in a Java SE environment, you can either use one of these two elements to reference a data source or use a set of properties to configure your database connection. In a minute, I am going to show you properties that we use to configure a database connection. Let's continue learning other configurations. The next thing that we need to do is to specify the managed classes included in your persistence unit. By default, your JPA persistence unit includes all annotated managed classes found in its root. If you want to include any classes that are located somewhere else, you can either reference them explicitly or include all classes from a jar file. Each class element needs to contain the fully referenced name of a class. Please be aware that these classes need to be available on your class path. Here you can see a commented example of adding our user class. And also, here is a commented example of specifying the whole jar instead of specifying all classes from the jar. You can also do other way around. You can add vividly classes to the persistence unit and exclude all other classes. To do that, you first need to use one or more class elements to explicitly specify which managed classes shall be part of the persistence unit. In the next step, you can use the exclude unlisted classes elements to exclude all classes from the persistence unit which were not explicitly included. The next step is to specify concrete persistence provider. If you use any proprietary features of your persistence provider, you should specify a dependency to it. You can do that by defining the name of the class that implements the persistence provider interface in the provider element. In this particular example, I specify Hibernate persistence provider. Now, let's add JPA properties. We are going to configure our database connection. Here you can see JDBC driver class, URL, username, and password. As you can see, URL contains the name of the database. That means that I already created database before running this example. So, not so much new properties here, everything should look familiar to you, and everything what we have learned with my students in the JDBC part of my Java from Zero to First Job course. The next step is to configure properties that would tell JPA implementation what to do with regards to schema. Since version 2.1, JPA can create a new database at startup and initialize it with a predefined dataset. You can activate and configure this feature by adding the following properties to your configuration. Jakarta Persistence Schema Generation Database Action. The action that you want to perform to manage the database schema. Supported values are none, create, drop and create, and drop. As you probably expect, the create option creates the database schema at startup, drop and create drops the existing database and creates a new one, and drop just removes the existing database. Jakarta persistence schema generation creates script source, the name of file URL to the script that creates the database. Jakarta persistence schema generation drops script source, the name of file URL to the script that drops the database. Jakarta persistence SQL load script source, the name of file URL to the script that initializes the database with a predefined dataset. Now, let's specify Hibernate dialect. What is it? A Hibernate dialect gives information to the framework of how to convert Hibernate queries, HQL, into native SQL queries. Since Hibernate is a database agnostic, it can work with different databases. However, databases have proprietary extensions, native SQL variations, and set subset of SQL standard implementations. And it looks like we're all good to proceed with our code example. Let me open demo class that I prepared for this lesson. In the main method, I create EntityManager factory first. To do this, I use persistence class first and call createEntityManager factory method and pass the name of my persistence unit. Once I create EntityManager factory, I can create EntityManager. Just call createEntityManager method on the EntityManager factory. The EntityManager instance represents a connection to the database. When using JPA, every operation on a database is associated with the EntityManager. Further, in a multi-threaded application, every thread usually has its own EntityManager instance, while at the same time sharing a single application-wide EntityManager factory. Operations that modify database content, such as store, update, and delete, should only be performed within an active transaction. That's why we need to start a transaction. When a transaction is active, you can invoke EntityManager methods that modify the database content, such as persist and remove. Database updates are collected and managed in memory and applied to the database when the transaction is committed. So, I created instance of a user type. This is entity type that we created during the lesson. I initialize object with some random state, and after that I call persist method. Now I want to get the reference to the transaction and commit transaction. I call getTransaction and commit methods. Also, we shouldn't forget that after we finished using EntityManager and EntityManager factory, we have to close them. Just call close method on the object that we initialized. Let's open my SQL workbench now and take a look what we have received. In scope of the lesson, I created two entities, user and project, when I showed example of composite primary key. You can also see here a sequence table. That is because we used auto-generation type for our user ID. Starting with Hibernate version 5.0, when generation type is selected as auto, Hibernate uses sequence style generator regardless of the database. In this case, MySQL Hibernate emulates a sequence using a table and is why you are seeing the Hibernate sequence table. Anyway, we reviewed today different generation types. You can select the one you like the most. And if we would take a look at the content of the user table, we are going to see that information about our user John Smith was successfully persisted. That is not all about the JPA. This is just a beginning. We still have a lot of things to learn about JPA and Hibernate in particular. But today we learned already just enough information to perform simple persistence operation. Congratulations with your first JPA coding example. As always, I am going to leave the reference to the source code in attachments to the lesson. I encourage you to download the source code and run it on your local computer. Play with the code and ask questions below this video in case something would remain not clear, and I will be happy to answer. Let's recap what we have learned today. In this lesson we created our first JPA project. I explained what entities in JPA are. We learned different annotations to configure entity. Some of the key annotations we learned are entity, table, column, ID, generated value. We learned different strategies for ID generation. Now you know key requirements for entity class. And after this lesson, you can easily create your own entity classes. We learned how to work with composite primary keys. You saw why we need and how to use temporal annotation. I explained how to avoid persisting some fields with transient annotation. We reviewed how to configure persistence of enum types, and we learned enumerated annotation. After this lesson, you learned what EntityManager Factory and what EntityManager is. Together we created our persistence.xml file and learned the key configurations. I explained transactions in JPA, and we talked about different transaction types in JPA. We compared what is the difference between GTA and resource local transactions. That's all what I wanted to share with you today. Thanks a lot for your attention. Have a great day and see you in the next lesson.